Hello everyone, I am 𝗪𝗏𝗃 pursuing second year BPC from Tribal Welfare Residential College, 𝗧𝗏𝗏 at Gannaram. Today I am here to discuss with you an interesting chapter. Before going to the topic, let me say you something. In our day-to-day life, we are going to face lot of problems. Every problem has a solution. In our universe, the people are face so many problems, but every problem there will be a particular and suitable solution. But the solution which are there in our life are differ from the solutions which are there in the chemistry. So today we are going to discuss about solutions. Friends, solutions is an interesting topic and it is a basic topic in chemistry. So let us go to the solutions. Yes, solution. First, what is a solution? Of course, we have read it in previous days, but what does its definition? A solution is a homogeneous mixture of two or more components. To understand better about solution, let us perform an activity. I am considering a beaker along with water and I am adding copper sulfate to this. If you observe the copper sulfate, I am adding copper sulfate to the water. After mixing thoroughly, what you will observe in it? Friends, chemistry is an interesting subject, but when you are entering into the chemistry lab, please be careful. After mixing thoroughly, what you will observe in this? Yes, the copper sulfate which we have added is completely dissolved in the solution and we observe the change in color. So, a solution is said to be a homogeneous mixture of two or more components. To understand better about solutions, let's make some lemonade in the summer. How many components does that have? More than two components, right? Water, salt, sugar and lemon juice. So, in copper sulfate solution, only two components are there and in lemonade, more than two components are there. So, a solution is said to be a homogeneous mixture of two or more components. Then what is homogeneous mixture? Homo means same. Then what is same? The uniform composition of the properties throughout the solution is same. If you observe the copper sulfate, if you take any part of the copper sulfate solution, there will be the presence of water and copper sulfate. And if you take lemonade, the sip as you sip the lemonade, the taste does not keep changing, right? It will remains the same taste throughout the glass. That is what a homogeneous mixture. And a solution is said to be a homogeneous mixture of two or more components. And think, if there is non-uniform composition in the solution, then what does it call as? Yes, if there is a non-uniform composition in the solution, then it is said to be heterogeneous mixture. Hetero means different. Heterogeneous mixture means in the solution, if there will be the non-uniform composition of the properties throughout the solution, then it is said to be heterogeneous mixture. So, I am saying that how many components does copper sulfate have? How many components does lemonade have? Components. In the universe, everything has a name. So, in the chemistry, in the solutions, the components have their own name. Let us know what are the components. Components of a solution. In the copper sulfate solution, the water is in larger quantity, right? And it dissolves the copper sulfate in it. So, solvent. The component of the solution that dissolves the water, that dissolves the other component in it called as solvent. So, the component which is in larger quantity and it has the capacity to dissolve the another component in it. So, the component is called solvent. And what about copper sulfate? It dissolves in the water, right? So, the component which is present in lesser quantity and it can dissolve in the solvent. So, such components are called solute. So, here solvent plus solute together forms the solution. Then we are saying solvent and solute. These are the components of solution. What does the properties does solvent and solute holds? Let us see. Properties of solvent. The component of the solution that present in larger quantity is known as solvent. As I have already said, the component which is present in larger quantity, that component is known as solvent. The solvent which is present, the solvent which has a greater dielectric constant is a better solvent. So here, greater dielectric constant. What is greater dielectric constant? Friends, have you ever heard about 𝗧𝗦𝗪𝗓 hydropower station? What is the specialty of that hydropower station? By using water, they produce energy. It means electricity. So, water has the capacity to store the electricity in it. So, greater dielectric constant means the ability to store the electric current in it. So, water is known as universal solvent. And solvents are also used in making perfumes, which we use daily, making drugs, and in the processing of various foodstuffs and in beverages. Let us move to the properties of solute. As I have said, solute is a component which is present in smaller quantity, and the solute particles cannot be separate from the process of filtration. Think, if the solute particles are completely dissolved in the solvent, then how it is possible? So, the solute particles which are there in the solution are not easy to separate from the hand picking method or physical properties. The solute particles do not settle down when undisturbed, that is, the solution is stable. If the solute particles are left down undistributedly, then the solution is said to be stable. So, we have learned about properties of solvent and properties of solute. Now, we will going to learn properties of solution. What does the properties does solution hold? A solution is a homogeneous mixture of two or more components. As I have said, homogeneous. Homogeneous something that has uniformity, similarity. A solution is a homogeneous mixture. And the particles which are there in the solution are smaller than 1 nanometer in diameter. And because of their small particle size, they do not scatter any beam of light through the solution, and that the light or the path is not visible. And I am saying about copper sulfate solution. In copper sulfate solution, the physical state of the water is liquid, and the physical state of the copper sulfate is solid, right? As we have now physical states, solids, liquids and gases. So, based on the physical states of solute and solvent, the solutions are of 9 types. Let us see what are the 9 types of solutions. If you take solvent as gas, the gas mixes with gas and it gives gas and gas solution. The best example is atmospheric air. In atmospheric air, there will be the presence of hydrogen gas, nitrogen gas, oxygen and carbon dioxide. Atmospheric air is the best example for gas and gas solution. And if the liquid mixes with gas, it gives liquid gas solution. Best example is chloroform mixed with nitrogen gas. Have you ever heard about chloroform? Yes. In previous days, surgeons used to give chloroform to make the patient unconscious. So, chloroform mixed with nitrogen gas is the best example for liquid gas solution. If the solid mixes with gas, it gives solid gas solution. And if you take liquid as solvent, the gas mixes with liquid and it gives gas liquid solution, oxygen dissolved in water. Have you ever heard or have you ever think how the aquatic life will breathe underwater? Because of there will be the presence of oxygen in the water. So, oxygen dissolved in the water is the best example for gas and liquid solution. If the liquid mixes with liquid, it gives liquid-liquid solution. That means ethanol dissolved in water. The physical state of the ethanol is liquid and the physical state of the water is also liquid. If they mix with each other, they give liquid and liquid solution. If solid mixes with liquid, it gives solid liquid solution. For example, glucose dissolved in water. In the summer days, when our body get dehydrated, to rehydrate our body, we will take glucose, right? The physical state of the glucose is solid and the physical state of the water is liquid. So, glucose dissolved in water is the best example for solid liquid solution. If you take solvent as solid, the gas mixes with solid and it gives solution of hydrogen in palladium. The liquid mixes with solid, it gives liquid solid solution, amalgam of mercury with sodium, and the solid mixes with solid, it gives solid solid solution. Copper dissolved in gold. Have you ever heard about ornaments? Yes, the ornaments is the mixture of copper and gold. The copper dissolved in gold is the best example for solid solid solution. As I have said about, water is a universal solvent because it has the capacity to produce electricity. So, based on the water as solvent, the solutions are classified into two types. Let us see what are they. On the basis of water as solvent, solutions are of two types. They are aqueous solution and non-aqueous solution. Aqueous solution, the name itself it refers aqueous. Aqueous means water. So, these are having water as solvent. In which solution there will be the water acts as solvent. So, that solution is aqueous solution. Before we have performed copper sulfate solution. In that solution, water acts as solvent. So, that is also example for aqueous solution. Then what about non-aqueous solution? It's simple, non-aqueous solution. There are the solutions having solvent is other than water. If you understand better, let me show you. I am considering a beaker along with a liquid. The physical state of this is liquid and I am taking ethanol. I have considered ethanol because the physical state of the ethanol is liquid, but it is not water, right? And I am adding alpha naphthalene to it. You may raise a question. You have said that the solutions which have solvent other than water, then it is said to be non-aqueous solution. Then why you are adding alpha naphthalene to it? Because I have said about solution is a homogeneous mixture of two or more components. If I only add ethanol to it, then how it becomes a solution? No, right? So, solution should contain two or more components. Now, I am adding alpha naphthalene to it. And here the solute is of alpha naphthalene and solvent is ethanol. And the ethanol is other than water. So, such solutions are called non-aqueous solution, right? I think may you understand about aqueous solution and non-aqueous solutions. Let us move forward. I am adding 2 spoons of copper sulfate or 1 spoon of alpha naphthalene. So, based on the amount of solute we are adding into the solution, the solutions are classified into 3 types. They are saturated solution, unsaturated solution and supersaturated solution. Before you are going to understand about saturated, unsaturated, supersaturated solution, let me tell you something. Think we went home for holidays. One day our mother prepared potato fry. How much we will eat? Required amount we will take. And think on another day our mother prepared bitter gourd curry. Then how much we will eat? Less than required. And think one day our mother prepared chicken biryani. Then how much we will eat? More than required, right? And if we take more than required, it's not easy to digest, right? To digest we will take Eno or Sprite, right? In these 3 examples I am saying required amount of food. So based on the amount of solute like, solutions are three types. They are saturated solutions, unsaturated solutions and supersaturated solution. Saturated solution. A solution which can't dissolve any more solute to the solvent, that means it dissolves required amount of solute in it. It has the capacity to dissolve required amount of solute in the solution. Such solutions are called saturated solutions. An unsaturated solution. It's simple. A solution that contains less than maximum amount of solute, it's capable of being dissolved. Such solutions are called unsaturated solution, like how we eat less amount of bitter goat curry. And supersaturated solution. A solution that contains more than maximum amount of solute that is capable of being dissolved at a given temperature. So a solution contains more amount of solute. Then how the solute is dissolved in the solution? Forcefully by raising the temperature or pressure of the solution. How we are adding Sprite or ENO to digest our food? Like that, forcefully raising the temperature, the solute particles which we are added to the solution can be dissolved. And see, to understand better, I am saying that I am considering two beakers. In one beaker, I am adding 30 spoons of salt, and in another beaker, I am adding 2 spoons of salt. Consider this beaker as A and this is B. Which one will be more salty? Absolutely. First beaker will be more salty and second will be less salty. So, but a spoon is not what we actually use in chemistry. If there is more amount of solute, we can say it as concentrated solution. And if there will be the less amount of solute, we can say it is dilute solution. Let us move forward. There are some properties which deals with the total number of solute particles and total number of solvent particles. Those properties are called colligative properties. Colligative properties. A colligative property is a property of solution that is depend on the ratio between the total number of solute particles to the total number of solvent particles. Total number of solute particles and total number of solvent particles, because I have said solute and solvent together forms the solution. So these properties deals with the ratio between total number of solute particles to the total number of solvent particles, and they depend on the number of solute particles. So these properties depends on the number of solute particles, and the physical state of the solution decides the solvent, because solvent is always present in larger quantity and it decides the physical state of the solution. And let us see what are the colligative properties. They are relative lowering of vapor pressure. If we decrease the vapor pressure, that is relative lowering of vapor pressure. Elevation of boiling point. Elevation means increase. Increase in the boiling point, it comes under elevation of boiling point. Decrease in the freezing point. If we decrease, it comes under depression in the freezing point. And osmotic pressure. Osmotic pressure. The pressure required to stop the osmosis is osmotic pressure. As we all know, osmosis, the movement of particles from low concentration to higher concentration, and we required some pressure to stop the osmosis. So that pressure is osmotic pressure. Based on the one of the colligative property, osmotic pressure, the solutions are again classified into 3 types. They are isotonic solutions, hypertonic solutions and hypotonic solutions. Here isotonic solutions. Iso means same. Then what is same? The solutions with same osmotic pressure, because I have already said these 3 types are based on the osmotic pressure. So the solutions with same osmotic pressure at given temperature are termed as isotonic solutions. If you consider any 2 solutions and if the osmotic pressure is same, so such solutions are called isotonic solutions. Blood with saline. The osmotic pressure of blood and saline is same. In hypertonic solutions, hyper means high, having higher osmotic pressure. A solution having higher osmotic pressure than some other solutions is hypertonic solution. If you are drinking alcoholic beer and the alcoholic beer has the higher osmotic pressure comparing with the body fluids. So, alcoholic beer with body fluid is the best example for hypertonic solutions. Then hypotonic solutions. Hypotonic solutions is quite opposite to the hypertonic solutions. Hypotonic solution, a solution having lesser osmotic pressure than some other solution is hypotonic solution. It has the lesser osmotic pressure comparing with the other solutions. Such solutions are called hypotonic solutions. For example, distilled water with body fluids. If you are drinking a glass of distilled water, the distilled water has nothing because it's already distilled, right? So the osmotic pressure of distilled water is less comparing with the osmotic pressure of body fluids. So distilled water with the body fluids is the best example for hypotonic solutions. Okay friends, in this lesson we have studied about solutions. A solution is a homogeneous mixture of two or more components. As I have said, homogeneous mixture. Homogeneous, something that has uniformity, similarity. The sip, as you sip the lemonade, the taste does not keep changing, right? The taste remains constant throughout the glass. That is a solution. And components of solution. The component which is present in larger quantity, we can say it as solvent, and the component which is present in smaller quantity, we can say it as solute. Properties of solute, properties of solvent. And based on the physical states of solute and solvent, the solutions are classified into 9 types. And we have already learned water is known as universal solvent, right? So based on the water as solvent, the solutions are classified into 2 types. They are aqueous solution and non-aqueous solution. In aqueous solution, the solvent is water, and in non-aqueous solution, the solvent is other than water, right? Based on the amount of solute we are adding to the solution. The solutions are classified into 3 types. They are saturated solution, unsaturated solution, and supersaturated solution. If you want to remember saturated, unsaturated and supersaturated solution, you have to remember what? Potato fry, bitter gourd curry and chicken biryani. And the properties which hold the solutions is colligative property. So based on the one of the colligative property, osmotic pressure, the solutions are classified into 3 types. They are hypotonic solutions, isotonic solutions and hypertonic solutions. I hope you have understand better about solutions, and let us meet in another class. My heartfelt gratitude to our secretary ma'am, our principal ma'am, my guide teacher, my escort teacher and all the teachers and my dear friends who supported me a lot to present myself here. And my special thanks to TSAT Nipuna. Thank you so much.